Hello friends, let us move on the next video of isoparametric elements and the numerical integration. In this video we need to do the study of how to find out the shape functions for the 2D element. Let us begin how to find the shape functions for the elements. So first of all, let us do the study of the shape functions of a two noded bar element. This is the problem of the 1D. But for the 1D also, how to find out the shape function, that method we need to define here. So let us take first of all a bar where there are the two nodes, and this is the point of a reference where p is equal to xi, p is equal to xi. So this is given. Now we need to first of all able to write first of all a displacement function. This displacement function we write through the Pascal triangle. Now here there are the two nodes, and in every node there is a 1 degree of a freedom. So this is the linear equation, this is the linear form. So when we are writing the linear form and the two term, so we need to write the two terms. Okay, so what is that? The first of all the constant term plus alpha x, so that we are writing u is equal to alpha 1 plus alpha 2 x. Hence this is equal to we need to convert this term into a matrix form. U is equal to that is, now here this is the 1 plus xi alpha and alpha into a singular matrix. So this linear form is converted into the matrix form. 1 plus xi matrix of 1 plus xi multiplied by singular matrix alpha 1 alpha 2. Then if I'm writing this term in terms of the u1 and u2, because this is my u1 at node 1, and this is my u2 at node 2. So u1 is equal to now at a u1 xi is equal to -1. This is already we are defining in a previous lecture. So here 1 is this one, and this xi is converted into the -1 multiplied by alpha 1 and alpha 2. Now u2 is equal to, this is the xi is equal to 1. So here 1 and 1. So this is the alpha into alpha 1. Hence we are getting alpha into alpha 1 alpha your single matrix alpha 2 is equal to d matrix 1 minus 1 1 1 in inverse of this one multiplied by single matrix u1 u2. Now how to solve this one? How to solve this inverse matrix? For this one we are using a cofactor method. What is that cofactor method? That is the cofactor transpose divided by 2a. That 2a is equal to determinant of the matrix, and determinant of a matrix is finding very easily. That is, if you are taken this term, then this term multiplied by minor of this term. So this multiplied by minor of this term. So minor of this term is this one. So 1 multiplied by 1 multiplied by 1. Then the second term, this second term, so -1. Now the second term, that is this one, -1. Okay, -1 multiplied by minor of this one. So minus 1 is equal to 1 plus 1, that is equal to 1 upon, that is equal to 1 half. Hence this is 1 upon 1 plus 1, that is 2, is equal to this process. So this one is calculated again with the help of the cofactor and the transpose of the cofactor. So first of all we need to write here, this one is the symbol, because this one is the -1 multiplied by to the power I plus j. So generally I is equal to 1, j is equal to 1 for the first term, so that is equal to -1 to the power 2, that is equal to plus. So hence I am writing this is plus, this is minus, this is plus, this is minus. Okay, why this is plus and this is minus? Because this one is the minus, this is the minus, that's why this minus plus. Actually this is minus and this is plus, but this one is the this one is vice versa. So this is plus, this is minus. So this one is the 1 1 minus 1 minus 1, and according to that we are solving this one, and we get this is the term, that is u is equal to matrix 1 xi into 1 half into displacement matrix, that is 1 1 minus 1 1 into alpha alpha 2. So this is the method to find the shape function. This is the method to find the shape function. Now let us move for the 2D bar elements. So again, that is u is equal to, here what we get, that is 1 xi 1 half this term. Again we are multiplying this one to this one, so we are getting the term L by 2 1 minus xi 1 plus xi alpha 1 alpha 2, that is equal to 1 plus 1 minus alpha xi upon 2 1 plus xi upon 2 into this one. So this is my n1 shape function, n1 shape function into, and multiplied by this one. So n1 is equal to 1 plus xi upon 2 into is equal to 1 plus xi upon 2. This is 1 minus xi, this is 1 plus xi. Now how this term comes, this is very important. This term comes from this term. Now multiply this one, row multiplied by column, row multiplied by column, this one and this one, there are the matrix. What is that? This is the 1 by 2 matrix, 1 row into 2 column. Now here, what is this matrix? 2 by 2 matrix, 2 row 2 column. So now what we get, this is the 2 and 2 are there, so there is a multiplication is possible. So what we get, 1 by 2 matrix, 1 by 2 matrix means 1 row and 2 columns. So here what we get, 1 row 2 columns, 1 row 2 columns. So 1 by xi 1 minus xi 1 plus xi. How we get this one? Again I am explaining. This is the my 1 by 2 1 by 2 matrix. What is 1 is row and 2 columns. This is my 2 by 2 matrix, 2 by 2 matrix. We know that this term must be a same one, then and only then the multiplication is possible. So this one is for completed, hence finally I am getting the result of 1 by 2 matrix, 1 by 2 matrix. What is that? 1 row and 2 columns, 1 row and 2 columns. So by multiplication I am getting 1 row, 1 row and 2 columns, column 1 and column 2. So 1 minus xi and 1 plus xi. So this is the multiplication, and line finally this is the 1 by 2 is there. So this 2 is entered here, multiplication. So this is divided by 2. So this is the n by 2. So this is the n, this is the n2. So this way we are finding the shape function. This way we are finding the shape function for the 3 noded bar. Again, now the 3 nodes, since this one is the 3 nodes, I am writing my u function is equal to alpha 1 alpha 2 xi plus alpha 3 xi square. Then convert this linear form into a matrix form. Since this one is the xi1, so this is the u1, this is u2, and this is u3. This is u3. So this is the u1, u2, u3. So again the term is 1 1 1. Now this one is the xi. So at u1 xi value is minus 1. So this is minus 1. This is square of this one, so 1. In u2 that is equal to 1. So this is the 1 1 1. While in a u3 this is equal to 0. This is equal to 0. So this one is the 1. This one is 0 0, because this is the term of alpha. So this is 1. While these both terms are 0, multiplied by alpha 1 alpha 2 alpha 3. Hence putting this value and finding the inverse. Again use the cofactor method. That is minus 1 to the power I plus j. According to that we can write the symbol first, plus minus plus minus plus 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 minus plus. Find the values, get the solution. This is the method. We are getting the solution here, and finally we are calculating these values, and finally we are getting these values. So this is 1 plus xi square upon this one. So what we get, what we get, that is the 1 plus r multiplied by this one, this matrix, okay, multiplied by this one, again 1 by 3 into 3 by 3, so I am getting the 1 by 3 into 3 by 3, so I am getting the first one row and three columns. So one row, this is the one row and three columns. So this is my n1, this is my n2, and this is my n3, this is my n3. So matrix manipulation plays a very vital role in a shape function calculations. Now let us move on a shape function calculation for the bar, for the rectangle, for the rectangle. So this is my job, this is my product, this is my element, this is my element. There are the four nodes: node 1, node 2, node 3, and node 4. Node 4. Now this is my xi eta coordinates, this is my xi, and this is my eta, and these are the coordinate values: plus minus, plus plus, this is minus plus, and this one is the minus minus, because this is comes into this, my looks like a, this is the my first quadrant, this is my second quadrant, this is my third quadrant, and this one is my fourth quadrant. According to that values are writing, these values are writing. So what we get here, at a node 1, both terms are minus. At node 2, this one is the minus, sorry, plus and minus. Here both are plus plus, here minus plus. Let us solve the problem for the shape function calculation. So what I am getting, my linear differential equation, there are the four nodes, and again at every node there is only one movement, hence this is the linear one. So what I am writing, that is alpha linear, four nodes, so there are the four terms. So alpha 1, alpha 2, phi, xi, plus alpha 3, eta, plus 4, alpha 4, xi eta. Hence converting this one into the matrix form, so that is the u1, u1, u2, u3, u4. So at u1, u2, e3, u4, I need to write these values. So here this one is the constant term, so this is the constant 111. Here is a change, here is a change, that is the xi, and this one is the eta value, xi and eta value. So if I look here, this is my xi, this is my xi, and this is my eta. So my bracket is xi and eta values, xi and eta values. So according to this value, I need to put the values here and develop the matrix. So according to that, I am developing the matrix like this way, multiplied by alpha 1, alpha 2, alpha 3 matrix. Then find out the inverse of this one. To find out the inverse of this one, use the cofactor method. By using a cofactor method, again now this one is the cofactor determinant of this one. So 1 by 4 is my determinant, and this is the matrix. I'm getting finally for I'm finding the inverse of this one. So that I'm getting the value, that is 1 plus xi, u is equal to 1 plus xi eta multiplied by this one. Now this is equal to 1 plus xi eta multiplied by this matrix multiplied by u matrix, displacement matrix. So this is my displacement matrix. The values of this one are from this triangle, sorry, this matrix. So I'm getting these values. So by solving this, I'm getting this term, this term, this term, and this term. So finally I would say this is my n1 term, this is my n2 term, this is my n3 term, and this is my n4 term. Oh yes, is hence my ni is equal to 1 by 4, 1 plus xi into xi dash, 1 plus n into for I is equal to 1 2 3 4. Hence my v is equal to n1 n2 n3 n4. So u into v, that is n1 into n3 n4, n1 into n3 n4 into delta matrix, that is the U or V matrix. So this term, this is very important. Keep in mind. So that is I put the value of xi and the xi. If I at a 1, at 2, at 3. Okay. So according to that, make the changes and develop the shape function. So shape function for the quadrilateral. Again now here number of nodes are increasing. Again how many 8 terms are there? So I need to write the 8 terms here. How to write? For that one I need to use the Pascal triangle. By using a Pascal triangle I need to develop these 8 terms, and accordingly I need to find out the U function. Now this is the 8 by 8 matrix. So again convert it into the matrix form of a 8 by 8 matrix form, then solve it and get the shape function. So this is the method just to find out the shape functions for the any type of the element. And this is the now here in a summary what we studied that in the beginning we are using the 1D problem. So for this one we are finding the shape function. That is, this is the shape function n1 n2. Now when the nodes are increasing, now the nodes are, instead of 2, the nodes are 3. Then the shape function is improved and changed, and this one is the n1, this is my n2, and this is my n3. So there are the three n1. Now this is my n1, this is my n2, and this is my n3. Now the another problem for the 2D. Now rectangle, I have taken the rectangle. These are the values of xi and eta, and accordingly I am finding the shape function. So the shape function, finally I am getting the shape function is equal to, this is my shape function n1, this is my shape function 2, this is 3, and this is 4. So if you look here this one, so this is equal to 1 minus minus, here plus, here plus plus, and here minus. So 1 minus zeta. Here both the terms are negative, one term positive, both terms are positive, and later on again the one negative term. So this is the shape function for the rectangle. So this is the shape function. So finally we are getting this one. So 1 plus hat, 1 plus theta. So initially both terms are negative, then both one term is positive, then both terms are positive, and finally again the only one term is negative. So this term is negative, rest of the positive. So this is the n1 n2. If there is the u and v direction, then this is the my shape function. So this is the method to find out the shape function for the any object. Thank you for watching the video.